Bismillahirrahmanirrahim. Welcome to the fifth lecture of data communication and networking. So it's a continued part of chapter 3. So today we are going to study about transmission impairment. خب حالا میخوایم که ترانسمیشن وقتی که شما دیتا یا سیگنال انتقال میتین کدوم سه چهار چیزا می در راه که او سیگنال چی میکنه دیسترب میکنه ضعیف میکنه یا قوی میکنه اون ضعیف میکنه قوی نیست قوی رو ما شما میتونیم که از امپلیفایر قوی کنیم خب میام دیگه signals travels through a transmission medium which are not perfect. The imperfection cause signal impairment. اینمی impairment عالمی چی است؟ اینمی سه چیز impairment. این چی میکنه؟ signal پرفکت خونمی باشه اونم imperfection چرا است؟ به خاطر اینمی سه چیز عالمی که میگم چرا است؟ این رو میگم impairment. This means that the signal at the beginning of the medium at the beginning the شروعات کی سیگنال اول کی شما انتقال میتین در سر beginning of the medium is not the same as the signal at the end of the medium چی معنی میده the beginning معنی میده وقتی که شما دیتا را سند میکنین وقتی که شما دیتا را ریسیو میکنین هر دویش میگه سیم نیست چرا وقتی فرق از این نقطه شما یک چی را انتقال میدین اینمی سیگنال فرض کن ای پوینت ای است ای سند شد در پوینت بی شما اینمیشه ریسیو میکنین دیگه اینمی سیگنال نمیوارد نمیباشه کام تغییرات سر یا کم میشه یا زیاد میشه اینمی واره کم زیاد یا کدام دیستربینگ دیگه داره از این خاطر میگه که اینمی امپیریمنت سر اینمی سیگنال افکت میکنه اور کدام سیگنالی که شما سند میکنین اونمی سیگنال شما ریسیو یا گون چینجز میاد so already what is sent is not what is received میگه کدام چیزی که سند کرده اون نمی چیز نیست که ریسیو شده so three cause of impairment or three causes of impairment or attenuation distortion and noise ما شما سی impairment عموما با سیگنال داریم که attenuation است attenuation چی رو میگه که سیگنال اپ و داون میشه ضعیف و زیاد میشه کم و زیاد میشه fluctuation که اون رو میگیم attenuation دیگه ایش distortion چی رو میگه که سیگنال شیپش عموما چینج میکنه دیگه ایش از noise چه در environment noises مختلف نویز پیدا میشه از الکترون پیدا میشه از موتور از کار از obstacle کلش پیدا میشه این از سر سیگنال افکت میکنه حالا میم که ما باید چی بخونیم حالا مهمترین چیزا چی از این لکچر ما attenuation باید بخونیم distortion باید بخونیم و noise باید بخونیم اول میم attenuation چیز بسیار ساده وقتی شما سیگنال از پوینت A تو پوینت B انتقال میتین اینمی در مابین obstacle می اونجا اکسیدنت میشه تکر میکنه سیگنال چی میشه ضعیف میشه اون میشه strength of a signal که است او کم میشه اور اینجا نوشته when a signal travel through a medium it loses energy چرا انرژی لاس میشه که او اکسیژن میکنه تکر میکنه امرای فرض کنید امرای تعمیرات امرای کار امرای انسان امرای درختها این انوایرمنت هر چیز است امرای اون چی میکنه تکر وقتی که تکر میشه انرژی لاس میشه انرژی که لاس میشه سیگنال ضعیف میشه از این خاطر میگه so it loses energy overcoming the resistance of a medium اون ساده این پوینت A فرض کنید صحیح دیگه ایش پوینت B از پوینت A تو پوینت B دیتا رو چی میکنین انتقال میتین سیگنال انتقال میتین از اینجا که شروع شد دیگه اینمی کلش انوایرمنت است حاله ده اینجا کار ماست بیلدینگ ماست تری هم است الکترون پروتون وقتی که اینمی سیگنال که میاد از کلش تکر میشه نه اکسیدنت میشه وقتی که اکسیدنت میشه کولیژن میشه در زبان دیتا کمیونیکیشن یا زبان تلگرام ما کولیژن میگه این کولیژن وقتی که کولیژن میکنه سیگنال انرژی لاس میشه وقتی که سیگنال انرژی لاس میشه استرنث اف سیگنال هم کم میشه خب این خواهد شد دیگه چطور ما سیگنال چی رقم ضعیف میشه حالا اینمی سیگنال چطور ما میتونیم که سترونگ بسازیم دیگه ما امپلیفایر یوز میکنیم در طرف ریسیور ما چی میکنیم وقتی که سیگنال ریسیو میشه در طرف ریسیور ما یک امپلیفایر انستال میکنیم که اونم امپلیفایر چی میکنه سیگنال پس قوی میکنه so amplifier are used to compensate for this loss of energy by amplifying the signal. اونم چیز طرف ریسیور امپلیفایر اینستال میکنیم، این امپلیفایر چی میکنه؟ سیگنال قوی میسازه. حالا میم که measurement of attenuation. دیگه attenuation رو شما فهمید چی از دیگه. حالا چی رقمی رو باید ما measure کنم؟ عموما ما attenuation چرا در سیگنال تغییرات میاد وقتی که هر چیز یا زیاد میشه یا کم میشه، گین میشه یا لاس میشه، هر چیز انرژی ایرا ما در دی بی با حساب دی بی چی رو میگیم؟ decibel دو کلکولیت میکنیم. So the measurement of attenuation is to show the loss or a gain of energy. The unit which will be decibel, which is used throughout the world. So keep in mind whenever somebody is going to ask from you that what is the unit of a signal or what is the unit of a signal energy, that will be dB, decibel. It may be loss, it may be gain, it may be amplifier, it may be attenuate. So dB is equal to 10 log of 10 P2 divided by P1. P2 is your output, P1 is your input. Okay. So it's simple a formula. We will see how we can calculate the signal strength. So attenuation, what is it now? You can see this figure. شما اینمی شکل میبینین، اینمی picture رو میبینین. اینمی signal اولنتان است، صحیح؟ اوریجینال است. وقتی که اینمی میدیم شد، از این میدیم که سیگنال اول انتقال میشه در پوینت بی که رسید طرف ریسیور اینجا رسید، اینمی سیگنال کمک چی میشه؟ چینجز میاد. اینجا امپلیتیودش زیاد بود، اینجا امپلیتیودش کم میشه. اونمی تغییرات در شیپ سیگنال آمد. چرا اومد؟ چرا که اونجا ما مختلف ابستیکل داریم در میدیم چی میشه؟ او انرژیش لاس میشه. وقتی که انرژی لاس میشه سیگنالی تغییرات میاره. از این خاطر سیگنال attenuated شد. اولی سیگنال این سیگنال ما چی میگیم؟ اولی attenuated، چرا که از ترانسمیشن میدیم پاس میشه، از attenuation پروسس پاس میشه، از خاطر اینا ما attenuated سیگنال میگیم. این سیگنال ضعیف شد. اولی ما میخوام که سیگنال قوی باشه، با خاطر از این طرف ریسیور باز ما یک امپلیفایر داریم. اون امپلیفایر چی میکنه؟ باز اینمی سیگنال امپلیفای میکنه که ما اینمی صدا را فرق یک ساوند است، ساوند چی باشه؟ امپلیفایر باشه، تیز باشه، خوب باشه که ما گوش کنیم. از این خاطر امپلیفایر استفاده میشه که سیگنال باز زیاد کنه، خوب کنه. صحیح؟ این اگزامپل اف چی بود؟ attenuation بود و چطوری را ما میتونیم که امپلیفای کنیم. میم یک اگزامپل 3.26 in a book. You can be search on a book as well. So suppose a signal travel through a transmission medium and its power is reduced to 1/2. So this means that P2 is equal to half of P1. In this case, the attenuation or the loss of a power can be calculated is, so you have a formula this one, dB is equal to 10 log of 10 P2 divided by P1. So same formula is here, 10 log of 10 P2 divided by P1. So you know that P2 is the half of P1. So P2 will be half of P1, 0.5 P1 divided P1 will be the same. So P1 will be cancelled, your result will be 0.5 10 log. So log of 10 0.5 is equal to minus 0.3, and when multiply with 10 it will be minus 3 dB. So now keep in mind one thing, you need to be keep in mind that whenever you have a minus value in a dB, so it means the signal is going to be reduced, the signal is going to be attenuated. وقتی که value منفی باشه، منفی dB معنی از این که signal ضعیف شده. صحیح؟ minus 3 dB means the signal is going to be reduced, signal strength is going to be reduced. So وقتی که اینمی value مثبت باشه، فرض کن این مثبت شه، فرض کنم مثبت شد، وقتی که پلس dB آمد از این معنی که سیگنال امپلیفای شد، سیگنال قوی شد. اینمی دو چیز همیشه یاد بگیرین. minus dB mean signal is going to reduce, plus dB mean signal is going to be amplified. So the loss of a 3 dB or a minus 3 dB is equivalent to losing 1/2 of the power. So just keep in mind. So coming to another example 3.27 in a book, you can search it on a book as well. So a signal travel through amplifier and its port is increased 10 times. So it means your P2 will be 10 times now. This means that P2 will be a 10 times of P1. In this case, that amplification can be calculated. We have a formula 10 log of 10 P2 dot P1. So you know about a P2. So P2 is equal to 10 P1. Put out values and your value is 10 dB. It's a positive value. It means the signal is amplified now. Amplified signal you have in a receiver side. So this is another example. So coming to another example as well, that example 3.28, which is the same example of figure 3.27. like he said, one reason that engineers use the decibel to measure the changes in the strength of a signal is that decibel number can be added or subtracted like mathematics. So when we are measuring a several point, like several point mean cascade. What it mean by cascading? When you are adding 2, 3, 4, 5 things, so that's called cascading instead of just 2. In figure 3.2, in this figure, a signal travel from a point 1 to point 4. In this case, the decibel value can be calculated. Now what is say? From point 1 to point 2, we have a minus 3 dB. A signal is going to reduce minus 3 dB. So then from point 2 to point 3, we have an amplifier. The signal is going to be amplified up to 7 dB. Then from point 3 to point 4, again the signal is going to be reduced. Why signal is going to be reduced? Because there is a collision of electron, collision of obstacle, etc., etc. So now we have different values of decibel. So decibel is equal to minus 3 plus 7 minus 3, and your result is plus 1. So plus 1 means that your final signal is amplified. Your final signal is amplifier signal. Okay, that's a simple example. So now coming to another example, example 3.29, same in a book as well, so you can search it on a book as well. So the question is, sometimes the decibel is used to measure a signal power in milliwatt. In this case, it's just a simple representation. It can be milliwatt, megawatt, micro, mega, etc. So in this case, it is referred to as a dBm. So most of the time we have a value in dBm in a telecommunication for a signal. So and calculated dBm is a 10 log of 10 pm. So already whenever you find the value, so the value will be in a m, in a milliwatt. So your pm is the power in milliwatt. Calculate the power of a signal with the dBm is equal to minus 30. So dB, you have already dB value. So formula is dBm is equal to 10 log of 10 pm. Okay, it's a signal. So now this pm is noun, which is minus 30. So log of 10 pm, pm is equal to minus 30. This dBm is equal to minus 30. So divide this minus 30 by 10, it will be minus 3. So log of 10 pm is equal to minus 3. So now we need to find a pm. So take anti-log of this formula. Take anti-log. When you are taking an anti-log, so your pm will be 10 power of minus 3 milliwatts. So this is your answer. This is the mathematics. This log, anti-log, exponential, how we can be replace a log by a value. So this is a simple way of finding a solution. So this is how you can find a signal in milliwatt. So keep in mind. So another example 3.30, the same in a book as well. The laws in a cable. This is a practical one. The loss in a cable is usually defined as decibel per kilometer. So dB per kilometer. Whenever you have a cable and you are going to install a cable and wants to be transmit your signal, so you can be find how many or how much your signal is going to be reduced per kilometer. So this is a way. So if the signal at the beginning of the cable is 0.3 minus 0.3 dB per kilometer, has a power of 2 milliwatt. So a cable have a power of 2 milliwatt, but the signal is going to reduce minus 0.3 dB per kilometer. Per kilometer, how much it is going to be reduce a signal? 0.3 dB. So what is the power of the signal at a 5 kilometer? Now we need to find a signal at 5 kilometer. So we have a per kilometer, so multiply with a 5, so it will give a 5 for the 5 kilometer. So minus 0.3 multiply with a 5, it will give you minus 1.5 dB. So this signal is for a 5 kilometer cable. So you have a cable. What kind of cable? It's matter, but mostly we use a optical fiber. So in optical fiber, from point A or from 0 kilometer to 5 kilometer, we have a cable. So how much will be the signal reduction? Minus 1.5 dB. So we can calculate the power is. So now this is a simple way. dB is equal to 10 log of 10 P2 divided by P1. So you have a dB already, minus 0.15 dB. We have it. So then this 10 will be going to be divide here. So 1.5 divided by 10, it gives another value. Then take anti-log of this. So P2 divided by 1 will be here. Then 10 anti-log of equation is 10 12 power of minus 0.15, because 1.5 is going to divide by 10, so your value will be minus 0.15. so find out this value by in calculator, so you will have a this value 0.1. So P2 divided by P1 is equal to minus 0.71. so, but we need a P2, we need a output power. How much power we need it? So P2 is equal to 0.71 P1. so we have a P1 which is equal to 2 milliwatt. so multiply with 0.7, it will be your P2 power, output power. What kind of power it means? Power of a signal. This is the power of a received signal. Okay, keep in mind, this is a simple way, but this is a practical way. You have a optical fiber cable per kilometer, you just find a per kilometer how much will be reduce the signal per kilometer, multiply with the kilometer, you will have a final conclude value or final conclude signal strength of a cable. Okay, so now coming to a distortion. Distortion is just a simple thing, just change the shape of the signal, just change the angle or a phase of a signal, just change the amplitude of a signal, anything. So distortion just like disturbance. So distortion mean that the signal change its form or a shape. Distortion occur in a composite signal. Composite signal mean you know about more than two signals are combined that can make a composite signal. So each frequency component has its own propagation speed traveling through a medium. The different components therefore arrive with a different delays at the receiver. That means that a signal have a different phase at the receiver than they did at the. Let's just see we have a composite signal. This is a composite signal. So it's a component of a component phase in this signal. Now we have this component, this component, this component. Just keep in mind this shape first of all. So now coming to the receiver end. This is your sender, now this is your receiver end. So in this end, this is the same phase, okay, but this phase is going to be changed. This was 0 and this was 90. Now the phase is going to change. Now this was a 0, this is a 180 phase now. So the phase of the signal is going to be changed. This is because of distortion of a signal. Then your output signal, your output composite signal will be, or your received composite signal will be distorted now. Just compare both of signals. So this signal is distorted now. So this is also called be attenuate, but up to extent we can be say like that, but it's a distortion of a signal. So just keep in mind what kind of distortion will happen. Is it shape of the signal can change the phase of a signal, can change the amplitude of signal, etc., etc. So coming to the third portion, which is more important in a signal, noise, which is always available in a cable, in a telecommunication environment. So noise, so we have a 3, 4, 5 different kind of a noise types. So the first kind of type is thermal. What thermal noise is? Random noise of electron, because we have an electron in an environment, we have electron in a wire, we have electron in the dishes, in a microwave dishes, in a any kind of antennas. So thermal noise can occur due to collision of electron. Collision mean accident, collision mean takar chemistry, this is called collision. Due to collision of electron we have a thermal noise. And also we have a induced noise as well. Induced noise mean from a motor or appliances, devices act or a transmitter antenna and medium as a receiving it, etc. So we have a motor, etc. A lot of a thing which can be create a noise, like moving of a car, moving of a people, sound of a people, they all we induce one. So another is a crosstalk. So same as above, but between two wires. Crosstalk, when people are going to be talk, like at the same time people are going to be talk, so in between the wire there will be a crosstalk. Crosstalk, you know about the crosstalk. So that's another is impulse. And what is impulse? Spike that result from a power line, like a lightning. Whenever you have a lightning after a before our raining, so you can be see a lightning in the sky, so that can affect a signal as well. You can see the cloud can always also be effect on a signal as well, in a wireless signal as well. So one thing keep in mind, noise is more important in your telecommunication and your data communication or your signal. So keep in mind, noise and attenuation both are more important. Again I'm telling you, noise and attenuation are more important, keep in mind. So now coming to a signal, we have a transmitted signal and received signal. So from point 1 we have a transmitted signal in this shape. So through a transmission medium, so when noise is added with this signal, so this is your noise, so this noise will be added with this signal, your output will be changed now. So your signal is going to be changed. So noise, what can say, let's see, you have a signal of this, and this is your, let's see, this is your noise signal, both will be added, your result may be nothing, maybe whenever, because it's make effect of interference. We can say interference. In this position we can have interference. We have a constructive interference, we have a destructive interference. Whenever interference is constructive, so your sound, your signal is going to be increased, strength will be increased. But whenever we have a destructive interference, so the signal will going to be reduced, or there will be nothing. Like how can, what kind, like this, see, this is your example, let's see, this is your one way signal, this is another signal. When this signal is going to be added, so both have a same phase, let's see, your constructive interference will be, your signal will be this one, it's a good signal. But whenever this destructive interference, so it may be, that will be, let's see, your result will be like another signal will be this one, your another signal will be this one. So this signal will be added with this signal, so this will cancel this one, and this will, sorry, this will cancel with this one, so result will be nothing, no noise will be, no signal will be there. So this is called destructive interference. So this can be happen in a signal. So keep in mind, noise is a more important phenomena in a signal. Okay, so due to a noise, signal in a receiver end is changed. So in a noise case effect شده signal دیگه اون signal که چی رقم بود او رقم نیست، حالا اون تغییر داد دیگه. Okay, so now coming to the another more important phenomena which you guys can be observed in your interviews question. So signal to noise ratio, SNR. So people will ask you, what is the SNR value of your signal? So signal to noise ratio, SNR. Signal to noise means signal divided by noise, simple. So what is signal to noise ratio? To measure the quality of a system, the SNR is often used. It indicates the strength of a signal with the noise power in the system. So it is the ratio between two power, signal power and noise power. So it is usually given in a dB. Again I told you, signal will be calculated in a dB. So it will be SNR dB. Same formula will be used. Formula is not going to be changed. Let's see, coming to the example. Example 3.31, same in the book as well. So the power of a signal is 10 milliwatt. This is 10 milliwatt. If this is 10 milliwatt, it means 10 milliwatt can be changed to 1 by 10 raised to power 3. It can be like that. Hope you guys understand it, because 10 milli means 10 raised to power minus 3. So when you want to 10 power 3, so just divide it. So milli will be coming to down, and in division will be plus, and the power of a noise will be 1 microwatt, 10 raised to power 6. Okay, so again minus 6, so you can be positive. Also coming to what are the value of signal to noise ratio and in signal to noise ratio in a dB. So solution is the value of signal to noise ratio and signal to noise ratio in a dB can be calculated as a follow. So signal to noise ratio, you have a signal value, you have a noise value. So I just change it. If you can see, signal value was 10 megawatt milliwatt, so it's coming to be in a division, and this was your noise, it's up because of making a value in a positive. Okay, so it will be 10,000. This is a simple noise, it's not in dB. So now we need to convert this value into dB. So 10 log of 10, you have a value, find it out. So you have a signal to noise ratio is for dB. So somebody is going to ask you now, so what is your signal to noise ratio? So you can say 40 dB, 40 dB. So keep in mind, so this value can be occur, just you can be calculated by this way. Signal value is 10 milliwatt, no need to be copy this one, and your noise value is 1 microwatt. So find out the value, it will be the same, this 10,000. Okay, This is the simple example. So just keep in mind signal to noise ratio, which is be always been a dB. So first of all you need to find signal to noise ratio in a simple mathematic value, then you can be find in a dB, because this formula can be like the signal to noise ratio in a dB is equal to like 10 log of 10 and simple value of signal to noise ratio. This is formula like this one. Okay, keep in mind. So this kind of a system we can say noisy channel. What noisy? Because there is a noise, that's why we can calculate by this way. But if we say that there is no noise, noiseless channel, no noise. So when there is no noise, so example 3.32 say that the value of signal to noise ratio and signal to noise ratio dB for a noiseless channel, because there is no noise now. वक्त की noise ना बोशो. So signal value, signal power divided by noise power is 0. So your signal to noise ratio will be infinite. So you have a accurate 100% accurate signal because there is no noise. So this is ideal case. You cannot be find this case in your real life, but this is an ideal case. Okay. So now coming to the another example. So one thing you need to be mind, whenever you have a greater signal to noise ratio, greater signal to noise ratio, okay, so it means your signal is accurate. But when your signal to noise ratio value is lesser, so it means you have a bad signal. Because why it's mean? Because first is signal, then noise. So noise is divided by signal is divided by noise. So it means when noise is we can say that when signal is a strengther, when वक्त ये नमी वर्षों में तो अनुभवगेन अगर सिग्नल कभी बोशा और नॉइस कम बोशा अगर तकसीम कर बहुत वैल्यू शा ज़्यादा में अजी खातिर सिग्नल टू नॉइज रेशियो ज़्यादा में मेगम की सिग्नल खूब है वक्त के सिग्नल वैल्यू कम है नॉइस ज़्यादा के तकसीम कुन वैल्यू शा कम में द इशारिया में अधिक मेगम के सिग्नल खराब है इनमी कंसेप्ट इंजो इस्तेफादा में शाले. We have a signal, noise and your output. So we have a large SNR. Large SNR means you have a good signal. Large SNR when it's occur when you have a noise. This noise is like a small kind of a noise. So it can disturb this signal and your output signal will be this one. But it's up to extent it's look like this one. It look like this one, but the shape is going to be changed. So this can say that you have a good SNR value, a large SNR value. Mean your signal is better than this one. Now how is this one? You have a small SNR, you have this signal, this is your noise, this will going to be add with this one. So your signal is completely disturbed. So it means when the signal is completely disturbed, so it means you don't have a good signal. So this is called small SNR value. Mean your signal is going to be bad now. So this is your fifth lecture. If you guys find any question, you guys can be asked. So just keep going to be read the book as well, because you have a couple of example in the book as well. So hope it will be helps you in your future as well. Thank you for your time.